well, let's go ahead and finish off this section. Okay, so in part D, it's the exact same polynomial as it was in part C. The only difference is that there's a negative sitting out in front of everything. So what does that do? Well, it flips it upside down. So now the ends are both pointed down. My intercepts didn't change, but this graph just flips upside down. So it's coming in from the bottom, and it's going to go up through the -3, curve it back around and go through the -2, curve it back up to go through +2, and then back down again to go through +3. And then put all your intercepts right on there. All right, and then your y-intercept, again, plug in 0 for all your x's, multiply everything in and out, including this negative sitting out in front. It comes out to -36. All right, so now let's look at the fun ones. Okay, so in example E, your intercepts would be -1 and +2. The degree, you just have the two x's here, but you got to keep in mind that this one's got an exponent on it. So that's really like x squared times x. So that's an x to the third. So it's an odd degree with only two intercepts. So if we look back at our multiplicity and how that affects the curve, anytime the multiplicity was even, so if it has an even power on it, instead of going through the intercept like it did for these, it's going to come up or come down, hit the intercept, and bounce off. And it just depends on what direction it's going to, where it's coming from. That'll tell you like how to bounce it. All right, so it's an odd degree. So the ends are going like that. Okay, so I'm going to come from the bottom. I'm going to come up. Now, the first intercept is -1, and that's the one where that has the multiplicity. So that's the intercept that's going to bounce. So it's going to come in. It's going to bounce off the -1, curve back around, and then go through the +2. Now, where students kind of get tripped up is when your intercepts aren't necessarily listed in numerical order, and they say, hey, the squared term is first, so that means the first intercept is going to bounce. Like, no, the bouncing or the sliding, that multiplicity is attached to that particular intercept. Okay, so just keep that in mind. All right, let's get the y-intercept, plug in 0 for your x's. So the y-intercept is at -2. Okay, let's go on to this one. Okay, so this is going to be, we have x squared times x times x. So that's an x to the fourth. And it's got a negative sitting out in front of it. So a negative even. Both ends are going down. Okay, so your intercepts, -5, -1, and 1. Now when we get to the -1, that's what has the bounce. So don't bounce it on the -5 or the +1, bounce it on just the -1. So we're going to come in from the bottom, and it has to go through the -5. It's going to curve around. And don't go through -1, you got to bounce it. So bounce off -1. And then it's going to curve down again and go through the +1. Okay, so there's your curve. And then the y-intercept, plug in 0 for x, and the y-intercept comes out to be a +5. Okay, so that's how the bounces are going to work. Let's try some of the other kinds. Okay, so example G, now we've got a multiplicity of 3. So the multiplicity is, it's odd, so that means it's going to slide when it gets to this particular intercept. which is going to be the -1. And it's just going to go straight through the positive 2, like there's nothing special about the 2. This is an x to the third times x. So another x to the fourth. That's positive, so the ends are both going up. Okay, so the left end is up, so I'm going to be working my way down. And I'm going to come down, and when I get to the -1, I'm not going to go straight through it. I'm not going to bounce it. I'm going to slide. So to get a good looking slide, you're going to make like 2 halves of a parabola. So one of the halves is up, and the other half is down. So in this case, the first half is up, and then you can lift your pencil up, and then right on, where you just touch the x-axis, draw a parabola going the other way like that. And that usually gives you a good slide. But again, it just kind of takes practice. Okay, so then we're going to slide it, or curve it back around and go through the positive 2. So sometimes with these things, it's more artistic than it is mathematical when you draw these out. But again, they're just sketches. So if yours is not perfect, like, don't panic. It's okay. If you just have the right shape with the right intercepts, that's all we're going for. Okay. So that's how you can do a slide. All right, now into some of the more fun ones. Here we go. So intercept is -1 and +2. They both have a slide. And if you multiply your x's, that's going to be an x to the 6th. So it's a positive even. So your ends are both going up. So coming from the top, I'm going to slide on the -1, come back up, and now I have to slide going through the +2. Label your intercepts. So that y-intercept is now at -8. Okay, so these graphs can look pretty complicated, but they're not usually too difficult to draw. Even the ones where it's got like, oh wow, lots of multiplicity happening. Just means it's like a roller coaster. All right, so we've got an x to the third, an x squared, and an x, so that's another x to the 6th. But it's got that negative sitting in front of it. So the ends are down. Intercepts are at 0, 4, and 2. Okay, so the 0, nothing special, and that's the first intercept in numerical order. So we're going to come in, just go through the 0, go through the origin, curve it back around, and now you're going to go through the +2, and you're going to bounce it. So bounce. But now it has to come back around to go through the +4, and you've got to slide it. Okay. So 0, +2, and +4. All right, this last one, the big one. If you multiplied all of your x's together, you got x to the third, then it'd be 6, 9, 11, and 13. So that's an x to the 13th. So left end is down, right end is up. 0 is at 0, -8, +8, -4, and 4. So lots of stuff happening. Okay, so on the -8, it's going to slide. Then it'll bounce on the -4. It'll slide on the 0, bounce on the +4, and slide on the final intercept of the 8. Okay, so slide through the 8, bounce off the 4, slide on the 0, bounce on the positive 4, and then slide through the positive 8. One thing that helps with these too, especially for those of you that have really tiny handwriting, try not to make your graphs little. I mean, if you're sitting there trying to graph something on something that big, that's pretty hard. So if you make it bigger size-wise, it gets a little bit easier to draw. And it's also a little bit easier to grade. Okay, so I told you as long as you have the right shape, the right intercepts, things are bouncing and sliding where they're supposed to, you know, that's all I'm looking for. I do get a little bit picky though on a couple of situations, so let's look at those. So let's say you were graphing this one up here, and you did something like this. Came through and then you bounced on the 2, but you missed. So let's say you went like that. Well, what's wrong with this? Well, there's only supposed to be the one intercept of 2, and you've now created another intercept. So you've crossed the x-axis more than what you were supposed to do. So if that happens, you know, just kind of erase it and start over. If the error is not too bad, like this one, it's pretty bad. But let's say you did it again, and you just sort of dip down on accident. What you can do to fix it is just put a big giant dot like that. This one you probably couldn't be because your dot would have to be super huge. But if if your mistake isn't that big, you can kind of cover it up. Otherwise, just take your eraser, erase it, and fix it. And same thing kind of for the slides. So let's say you meant to slide through like this intercept right here, and you kind of go like this. Well, what's wrong with that? Well, your slide is early. You slid up here, not actually on the intercept. So your slide's got to be on the intercept. And let's say you went something like that, and that was supposed to be a slide. Well, you just created 2 extra x-intercepts. So you're going to want to fix it. So the bounces and the slides need to be accurate. Otherwise, it's not an accurate graph. So yeah, you do have to have the right shape, but you have to have the right bouncing and the right sliding at the right possible time in the correct and drawn in the correct way. Okay, so that's going to do it for this section. Sorry for a little lengthy video. So just give the homework problems a shot, and just let me know what your questions are.